Hello everyone, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Okay, today I would like to explain about cutting fluids, importance of the cutting fluids, what are the different types of the cutting fluids, and what is the functions or applications of the cutting fluids. So this one is the outcome of this topic. At the end of the course, the students should be able to recall the importance of geometry of cutting tools, coolants, and tool materials for the analysis of the material behavior during the machining or manufacturing processes. Okay. So last class we already discussed the tool materials. What are the different types of the tool materials? Okay. So in this class we will see the importance of cutting fluids, why we have to use cutting fluids in machining process. Okay. So in last class we already discussed the tool materials. So tool materials, low carbon tool materials, and the high speed steel materials. So most probably in industries, low carbon tools and high speed tools. So we'll use these types of tools are used. So the main drawback of the carbon tools and high speed tools are this is the hot hardness. The hot hardness is very less. Hot hardness means if the temperature increases, automatically the hardness of those cutting tools will be decreased. Suppose for the carbon tools, if the temperature of the tool bit increase to above 200 degrees centigrade, the hardness of the particular tool will be decreased. It will not return to the original condition. So when the hardness of the tool decreases, automatically the wear rate of the tool will be increases. So to address this problem, to rectify this problem or to reduce this problem, we have to decrease the temperature of tool bit when machining process. Okay. So to reduce this temperature of the rising temperature of the tool bit, so we have to use the cutting fluids, because we know the process. Suppose this is the workpiece, this one is the workpiece. So this one is the cutting tool. So this is the material removed in the form of the chips. You know this one. So most of this is the cutting portion here. So the friction between this tool and the workpiece, so automatically due to this friction, heat will be generated. Most of the heat, it means 80% of the heat will be dissipated, will be passed through the chips. 10% of the heat received by the workpiece, 10% of the heat will be received by tool bit. So due to this rising heat, automatically the hardness of the material, the hardness of the tool bit will be decreased. So when the hardness of the tool bit reduced, automatically the wear rate will be increased. So automatically the tip of the tool will be spoiled due to that less hard, due to the smoothness of the tool bit. Okay, so automatically the life of the tool will be reduced. Then next the uses of the tool will be reduced. Automatically we will get the rough surface finishing. So to address this problem, to reduce this problem in machining, so we have to use the cutting fluids. So that is the main importance of the cutting fluids. So cutting fluids, what is the first of all we will see the history of these cutting fluids. Okay, so essentials in metal cutting operation, the main is to reduce the heat and friction. Okay, so by the help of the cutting fluids, we can reduce the heat, we can reduce the coefficient of the friction also. Okay, centuries ago, initially water used on grindstones, that is the just like water is used as a just like cutting fluid for the grinding the stones. Hundreds years ago, tallow used, so but it did not cool. Tallow means this is the just like solid fatty solid, so fatty of any just like vegetable or any animals also. Okay, next Lord's oil came later, but turned rancid, so it was the usage was became bad. Because Lord oils means just like fig fat. Okay. So next early 20th century, saw soap added to the water. Saw soap, this is the just like olive oil something added to the water. So next soluble oils came to uh, into picture in the machining process in 1936. Next chemical cutting fluids so comes into picture, comes into action in 1944. So this is the just like history of cutting fluids. Now we'll see just like what is cutting fluid, what is the importance of the cutting fluids, what are the properties and purposes of the cutting fluids. We'll see. Okay, so either liquid or gas, so that is used on the tool chip interface during the machine, so that is called a cutting fluid. We can see there are three types of the cutting fluids, either liquid type cutting fluids or gas type cutting fluids or solid type cutting fluids also. You can see the main intention of the cutting fluid is to reduce the friction or reduce the heat. Okay, first the main properties or purpose of the cutting tool, cutting fluids, so that one is the to reduce the friction. Okay. So friction between the cutting bit and the workpiece. Okay, so due to this friction, heat will be developed. That heat is taken by just like most of 80% of the heat will be taken by the chip. That process we already discussed in previous class also. Okay, the first one is to reduce the friction. Cutting fluid reduces the friction at a tool interface. We know that already. So this is the workpiece. This is the chip. Material will be removed in the form of the chip. This is the cutting tool. Okay. So due to the interaction or the compressive force occurred by the tool against the workpiece, just like heat will be generated. We know this one. Okay, cutting fluid reduces the friction which develops or which occurs between the cutting tool and the workpiece interface. So also at tool workpiece interface also. So here the contact between the tool and the workpiece also. Okay. Next, since frictional coefficient is reduced at the tool chip interfaces, automatically so flow of chip increases. So automatically this flow of chip increases on the rack face of the tool. So otherwise coefficient of friction or power consumption is also increased. Okay. So due to this application of the cutting fluid, we can reduce the friction and we can increase the we can reduce the power consumption also. Okay, utilization of power will be improved by the effect of cutting fluid also. So next one, to improve the surface finishing. Okay, so due to this overheat, the hardness of the tool will be decreased. Automatically tip of the tool will be weird, so automatically we will get the rough surfaces. To maintain the good surface finishing, we have to provide the cutting fluids. So that is the second application or purpose of the cutting fluid. Next, to cool the tool and the workpiece. Okay, because in this case 80% of the heat taken by the chip, 10% is taken by tool bit, and 10% is taken by workpiece. Okay, so in this way heat will be dissipated. So the heat of the tool and heat of the workpiece will be reduced by the help of the cutting fluids. So next, fourth point, to move the chip quickly. Okay, so because overheating, there is a chances to build up edges. Build up edges means the chip welded with the surface of workpiece tool bit. Okay, so that is the problem of build up edges. So build up edges. So to reduce this one or to remove this one, just we have to provide the cutting fluids. Okay, so cutting fluid addresses the finally cutting fluid addresses the heat to be reduced from the workpiece and tool. Next, to reduce the frictional coefficient or friction between the interface of the tool bit and workpiece. Next, to overcome the build-up edges on the tool bit. Okay, so these are the main advantages of the applications of cutting fluids. Next, important properties of the cutting fluid. It should absorb more heat. Okay, so the cutting fluid should have the ability to absorb more heat. Okay, we have to prepare this type of cutting fluids. It should reduce the friction. Okay, next, it should not be corrosive in nature. If you use the water, so water has the corrosive nature. So different types of the cutting fluids are available in the market. We can use those cutting fluids for the uncorrosive surface finish. Next, it should have low viscosity. Okay, so high viscosity fluids disturb the machining process and inconvenience to the operator also. Next, there should be economical also. Okay, so these are the main properties by the application of the cutting fluids. Next, so types of the cutting fluids. Okay, mainly three types of the cutting fluids are there. One is the liquid type, another one is gaseous type, and then one is solid type. Here, liquid type and solid type, just a gummy type, and we can use the argon and carbon dioxide also, and air, natural air also. We can use those fluids or air gases for the cleaning and machining of the cleaning the just intersurface of the machining process or interface of the tool bit and the workpiece. Okay, so we'll see. Generally, cutting fluids are employed in liquid form. Most probably 90% of the fluids, cutting fluids are in liquid form, but occasionally also employed in gaseous forms also. Because if you take the grey cast iron, so the liquids will react with the grey cast iron. In the case of machining of the grey cast iron, we have to use the gases instead of liquids. Okay, so we'll see that one also. Only for lubricating purposes. Often solid lubricants also employed in machining and grinding process. Okay, so three types of the cutting fluids. Most of the cutting fluids are in the liquid form. So only some occasional cases we will use the either gaseous form or solid form. Okay. So the primary functions of the cutting fluids, we will see what are the primary, very important functions of the cutting fluid. Already discussed that one also. Lubricating the cutting process at cutting speed, okay? Just to reduce the friction between the workpiece and the cutting tool. Next, cooling the workpiece at high cutting speed. Due to high cutting speed, the workpiece temperature will be increased, and the next temperature of the tool bit also increases. So to reduce those temperatures, we have to use the cutting fluids. Next to pushing away chips from the cutting zone. Okay. So just mm, so we're pressurizing this cutting fluids, we can sifting the chips from the cutting zone. Okay. Next to properties of the cutting fluids, we'll see what are the main properties already discussed. Okay, it should possess good lubricating properties. Okay, to reduce the frictional losses. Good lubricating properties to reduce the frictional force. It should be non-toxic. Okay, should not react with the uh, surface of the material, or should not toxic to the human bodies, operators bodies also. Okay, so how to take care to prepare the cutting fluids also. Next, it should be chemically inactive. If it is chemically active, automatically that reacts with the uh, surface of the material. Automatically, the color and the surface finishing also will be disturbed. Or just if it is chemically react with the human body, so that leads to toxic of operators health also. Okay, it should not be very easily, sorry, it should not very easily flammable. Okay, it should not be flammable. Okay, so otherwise it leads to some hazardous. Okay, it should be stable in use and storage also. Okay, in the uses and in the storing condition also, it should be stable. Okay, high heat conductivity. The conductivity of the cutting fluid should be high, because of that conductivity property, the this fluid can take the heat from the workpiece and the tool bit also. So these are the properties of cutting fluid. We have to maintain these properties. Okay. So next we'll see the types of cutting fluids. What are the different types of the cutting fluids? First of all, we'll see the gaseous type. Gaseous type. Suppose machining on some materials like grey cast iron. So grey cast iron become inconvenient or difficult if any cutting fluid is employed in the liquid form, because that reacts with the liquid form. Okay. So in such cases, so it means in the liquid form, if you apply the liquid form of the cutting fluid, it is very just inconvenient or very difficult to perform the machining process on grey cast iron. So in such cases, in that occasional cases, only air blast is recommended for cooling and cleaning only. Okay, so for the cooling purpose and the cleaning purpose also. Okay, so but gaseous type is the very poor lubricating properties. Uh, so it cannot reduce the frictional coefficient between the workpiece and the tool bit. Okay. So next, some commonly used gases cutting fluids. We will see what are the different gases fluids are available in the market. Next, the first one is the air. So they are very common. Effective coolant. It is very effective coolant when it is used in the sub-zero coolant state. Okay. So because it can take the heat from the workpiece or tool bit. So next one is the carbon dioxide. Carbon dioxide has excellent heat extraction process property. Okay. So the conductivity of this carbon dioxide is very high. So we can use that one also. Next, sometimes we will use the organs. Okay. So to control the for the just cleaning and cooling and control the flammability also. So this is very important. These are the three types of gases type cutting fluids. Now we'll see the different types of liquid fluids. Okay. So first liquid type is the water. Water is the common fluid we can use. So, but due to its very high specific heat, very high conductivity, so it is considered as the best coolant, hence employed where cooling is most urgent. So if the purpose is only just to reduce the temperature of the just like workpiece or just tool bit, you can use this water. Okay. But poor lubricating properties, it has the tendency to cause rust and corrosion, because that leads to rusting and corrosion processes. So that is the main defect of the water. Okay, so for this one you have to add some liquids or chemicals to water. Then you can use this water mixing, just like chemicals, cutting fluids. We'll see soluble oil or emulsions. So oil based cutting fluids, because the some type of oil which is not chemically reacted with or chemically mixed with the water. So oil water will use this one. Okay, it is non-expensive. Just oil containing some emulsifying agent, just like soap, just additives, just like EPA additives, uh, just like excess pressure, like next to together. So these soap and additives, like, so together called as the cutting component, is mixed with the water. So in the suitable ratio, the ratio is equal to 1 to 2 or 20 to 30, just like 1 to 20 or 2 to 50 range. Okay, that is the next. Oil tends to reduce the corrosion, because this is the mixture of oil and water, like water. Okay, so water doesn't mix with the oil. Okay. So this oil act as a just corrosion resistance. This oil used as the corrosion resistance, and water used to reduce the heat of the workpiece or tool bit. Okay. So this is the oil plus water. So this is the soluble oil. This is very best cutting fluid. This milk-like white emulsions, that is called soluble oil. Okay, is very common and widely used in machining and grinding processes, because oil and water, the drawback of the water, that it has a tendency to cause rust and corrosion. That is addressed by, that is reduced by the mixing of the oil. Okay, the oil mixed water, we can use that one. Okay, so that oil just causes to reduce the corrosion, and water causes to take the heat from the workpiece or cutting tool. So oil water, this is the, it is called soluble oil. The soluble is oil is a very common cutting fluid in our industries. Okay, next one is the cutting oil, just like a mineral oil and straight fatty oil. So this type of, another type of liquid type cutting fluids. Okay, so cutting oils are generally compounds of mineral oil, to which are added to the dessert type, and the amount of vegetable, animal or marine oils. So those are called straight fatty oils. Okay, simply called as lard oil. Okay, so that is the fatty, just like fatty of animals or minerals or vegetables. Okay. So the main purpose for improving the spreading and wetting and lubricating properties. Okay. For the spreading of machining area and wetting of that intersection area. Next, lubricating the lubricating purposes. So for this purpose, we can use the this type of cutting oil. So straight fatty oils like lard oil were not used directly due to their adhesive effect. So adhesive effect on the health of the operator. Okay. So due to it, gummy characters, just like it forms gumminess or some gel type layer. It is formed on the workpiece, just like workpiece. So as and when required, some just like high pressure additives, that like sulfur or chlorine is also mixed to reduce the friction and adhesion, stickiness and build up edges formation also. So these are the another type of the cutting oil. Next to chemical fluids. So these are occasionally used fluids where water based, just like where some organic and inorganic materials are dissolved in waters like alkali, like sodium carbonate, potassium carbonate, etc. So to enable the desired cutting fluid actions, so this type of chemical fluids also just like available in the market. Okay, so two types of this type of fluids. One is the chemically inactive and the active surface also. Inactive for the high cooling purpose, anti-rusting purpose, wetting. So, but less lubricating. So, in case of as for a requirement, for the requirement is high cooling and anti-rusting, we can prefer this chemically inactive type. Chemically active type, there is the moderate cooling and lubricating purposes. Okay. So based upon our primary requirement, you can use this type of the cutting fluids. Next, solid or semi-solid lubricants also. So either apply directly to the workpiece or as an constituent in the tool also. Okay. It reduces the friction, thus automatically cutting forces and temperature, tool wear also. Okay, example, paste, waxes, just soaps or graphite, molybdenum disulfide. So this type of semi-solid lubricants you can use. Next, cryogenic cutting fluids also you can use. So those type of fluids are available in the market. Extremely cold, so cold fluids like liquid carbon dioxide and nitrogen are used in some special cases for effective cooling without creating much environmental pollution and health hazards. So in those cases, just like in that cases, you can use this type of cutting fluids. Next, we'll see some economical advantages to using of cutting fluids. We know that we already discussed this one, reduce of the tool cost, because by applying the cutting fluids, we can improve or we can increase the life of the tool. So because we can reduce the heat of the tool when performing machining, automatically the life of the wear rate of the tool bit will be reduced. Automatically the life of the tool will be increased. Okay, so based upon that, so we can reduce the tool cost. Okay, next, to reduce the tool wear and last longer also. We can increase the speed of the production speed also we can increase it, so by using the cutting fluids. Next, reduce the heat and friction. So higher cutting speeds, we can maintain the higher cutting speeds for the machining operations by applying the cutting fluids, but by addressing just by reducing the frictional reducing the friction also. Next, reduction of labor cost also. Okay. So there are so many advantages of uses of this cutting fluids. Tools last longer, requires less less downtime also, because of this applying of this cutting fluids. You can maintain the consistency in the machining process, and you can reduce the just like cost per part also. Okay, reduction of power losses. Okay, so if you apply the cutting fluids, automatically high application of high power, uses of the power will be reduced. Next, to friction reduced, so less power requirement. So this is the power saving by applying the cutting fluids. These are the most economical advantages of the cutting fluids, you can see. Next, these are the principles of cutting fluids. Already discussed this one. Mostly extreme pressure additives, EPA additives. Okay, the chemicals like chloride, phosphate, sulfide, so present in the cutting fluids under high pressure and temperature, chemically reacts with the work material. So at the chips under surface and forms a thin layer. So because of this high pressure additives, some thin layer is just like is formed on the workpiece that leads to smooth machining. So the low shear strength of that reaction layer helps to automatically that leads to reduction of the friction. Okay, so the main advantage of this one, because of adding up this one, friction or coefficient of friction will be reduced. The friction between the workpiece and tool will be reduced. Okay, to form such solid lubricating layer under high pressure and temperature, some extreme pressure additives, so EP additives we have to add. So these are the just like some ratios of EP additives are given. We can see this one. So this is just a cutting fluids effect on the cutting tool action. Uh, Lower heat created by plastic deformation of the metal. Okay, friction at the tool and chip interface, that will be decreased by applying the cutting fluids. Less power is required for the machining because of the reduced friction. Okay. So next, prevents the build-up edges. We already told build-up edges occurs due to the overheat of the chip and the face of the tool also. So that will be decreased. So the build-up edges problem uh, will be removed by the help of applying the cutting fluids. Next, surface finishing of work greatly improved. Smooth surface finishing will get, continuity, consistency in machining will get. Okay, so these are the main advantages of application of the cutting fluids. Okay, so these are the different references books we can refer to understand this topic. So thank you listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.